In this presentation, we are going to look at the principle of inclusion and exclusion in the context of counting problems. So we're going to use a school example about students who do sports, okay? Among a group of students, 50 play cricket, 50 play hockey, and 40 play volleyball. 15 students play both cricket and hockey, 20 play both hockey and volleyball, 15 play cricket and volleyball, and 10 play all three. Okay, so if every student played at least one game, find the total number of students and find out how many only played cricket, only hockey, and only volleyball. Okay, so straightforward enough. What we're going to do is we're going to take a sort of formulaic approach here. We're going to sort of focus on the principle of inclusion and exclusion. Okay, you could tackle this problem with diagrams and rationalize like that, and that's actually a good approach. But in this case, we are going to look at this principle more intensely, more thoroughly. Okay, let's just go back to what we were told here. Let C be the set of all students who play cricket. Let H be the set of students who play hockey, and let V be the set of students who play volleyball. Okay, so we're giving the following pieces of information. The cardinality of C is 50, the students who play cricket. Cardinality of H is 50, students who play hockey. Cardinality of V is 40, okay. The cardinality of C intersection H is 15. Cardinality of H intersection V is 20. The cardinality of C intersection V is 15. And finally, the cardinality of C intersection H intersection V is 10. That's the students who play all three sports. Okay. So what is the principle of inclusion and exclusion? Well, it's a fundamental concept in counting problems used to calculate the size of unions of multiple sets. So the principle helps to avoid overcounting elements that belong in multiple sets by systematically including and excluding the intersection of these sets. So this is a two-set problem. We have two sets A and B. The cardinality of A union B is the cardinality of A plus the cardinality of B minus the cardinality of A intersection B, okay? So that's a number of elements in each set. That's what I mean by cardinality. And if you recall this, you've probably seen this previously in probability, it is to prevent the double counting of the items that are in this intersection. They get counted in the context of A, they get counted in the context of B, so they get counted twice when we're talking about the union, so it's just to prevent them getting double counted that we would subtract the intersection. Now, we're dealing with a three-set problem, so this is why this is interesting. So the cardinality of A union B union C is cardinality of A plus cardinality of B plus the cardinality of C, okay? And what we're going to do now is subtract the cardinality of each of the intersections. So the minus the cardinality of A intersection B, minus the cardinality of A intersection C, and minus the cardinality of B intersection C. Okay, so this is very similar to the last instance, but we have counted the intersections of each item, but essentially what we've now done is we have removed the intersection of all three, so we actually have to put it back in. Okay, you sort of think about it a second. What we're taking out, and what we're taking out. What we've put in the first instance with A, B, and C, what we're taking out with the intersections of A and B, and A and C, and B and C. So essentially what we've gone, if they've sort of gone one step too far in this exclusion, so we have to re-include the intersection of all three. So we go plus of A intersection B intersection C, the cardinality of that, okay? So essentially this corrects for the triple counting. Anyway, that's it really. So let's get on to our problem here. The total number of students is given by the principle of inclusion and exclusion, okay? So we have cardinality of C is 50. the cardinality of H is 50, the cardinality of V is 40, okay? Now we're going to subtract the intersections, the double intersections, so to speak. So minus 15 for cricket and hockey, minus 20 for hockey and volleyball, and minus 15 for cricket and volleyball. Okay, and we're going to put back in the students who play all three, so it's plus 10. So we have 50 plus 50 plus 40, minus 15, minus 20, minus 15, plus 10, and that gives us 100 students. Okay, so what we're going to do now is just look at the students who play only one game, okay? So what we are going to do here is, this is a sort of very similar to the principle of exclusion and inclusion. You spot this now shortly. So we're looking at the cardinality of C only, the students who play cricket only. Well, that's the students who play cricket minus the students who play cricket and hockey, minus the students that play cricket and volleyball. But we're going to do something very interesting here. We've double counted some of these students, okay? So essentially what we have to do is put them back in to prevent triple counting. So we're going to add back in the students who play all three sports. And the reason is we have to correct for the overcounting, okay? So it's a little bit counterintuitive there, that plus cricket and hockey and volleyball, okay? But think about it, because you've actually sort of subtracted these values twice already, which is what I'm getting at. You've done it you've subtracted it when you went from cricket and hockey, and you subtracted it when you looked at cricket and volleyball. Okay, so you've done it twice, so it's to correct for that mistake. So anyway, 50 minus 15 minus 15 plus 10 is 30. So 30 students play cricket only. Okay, and something similar here for the hockey only, which turns out to be 25. 50 minus 15 minus 20 plus 10, which is 25. And only volleyball, which is 40 minus 15 minus 20 plus 10, which is 15. Okay, so that's it in a nutshell. So it's essentially the principle of inclusion and exclusion is very useful in this context. So to sum it all up, there are 100 students, 30 play cricket only, 20 play hockey only, and 15 play volleyball only. Okay, we'll leave it there.